Are we live? I think we're here. So, hello again, welcome. I'm going to keep going with the problem solving and try not to yell into the microphone again if I can help it. Yeah, let me get into it here. So, have yet another problem. I think after this problem, I'm going to so design phone directory is what we want to do. I think after this, I'm going to go hit the gym, get some food, take some time, and then come back to it. So, design a phone directory that initially has max numbers and empty slots that can store numbers. The directory should store numbers, check if a certain slot is empty or not, and empty a given slot. Implement the phone directory class. Has a max numbers empty slots that can store numbers. The directory should store numbers, check if a certain slot is empty or not, and empty a given slot. Okay, so you can store the number, check if it's empty or not, and empty a slot. Okay. Implement the phone directory class. Phone directory int max numbers initializes the phone directory with the number of available slots, max numbers. Int get provides a number that is not assigned to anyone. Check int number returns true if the slot number is available and false otherwise. True if the slot number is available and false otherwise. Void release int number releases or recycles or releases the slot number. Okay. Check returns true if the slot is available, otherwise false. Okay. Get, check, release, check. Null 0, 1, true, 2, false, null, true. New directory, get any available phone number, you assume returns 0. Assume it returns 1. It's available, returns 2, the only number that's left. No longer available. Okay, I think this is kind of a simple one. 10 to the 4th. Oh, that's 100,000. It's 10 to the 4th. No, 10 to the 4th is 10,000. 10 to the 3rd is 1,000. 10 to the 5th is 100,000. Number is just 0 between 0 and max numbers. Well, I guess one less than the max numbers inclusive, we'll say, or just max numbers exclusive. Most 2 times 10 to the 4th calls we made to get, check, and release. Yeah, so I don't really know. It looks like I could probably use a hash set to do this. And an unordered map, you know. I wouldn't even say necessarily a unordered map. I mean, it could just be an ordered set. I mean, what do you really need a map for? Okay. We'll put a so numbers, max numbers, and then also so there's the max numbers will be kind of internal, and then we're also going to use an unordered set of numbers, current numbers, and max numbers equals. Maybe I'm just missing something, but this doesn't seem particularly, I guess, interesting. I don't know. We'll see. We'll see as we go. I'll probably realize something, and then my thoughts will change a bit. So my thinking is, getting a number, we're just going to cycle through. You know, actually. There might be a better way to implement this get function. just thinking about how they might implement this get function. Basically, if you imagine like an array, you could implement this in sort of like an array, and you kind of punch holes in the array, and then find your sort of the get is sort of to try to find a hole in the array. And I think you could do it in and the get's going to find an open hole, more or less, right? Could use a binary search. Yeah, I like that better. I was thinking about how I could finagle this to get. Think of how I could finagle this to get. Sorry, let me just think. I was thinking of how I could finagle this to get. Let's give me a moment. Spam calls. I'm pretty sure it's spam. To make this basically amortized constant. To make this sort of a constant time call, but actually I think it's better to I think it would be better to I want to do this in logarithmic time. Thinking of a data structure that we can use. Okay, so this is a little bit more interesting than I thought. I take it back. Is it an interesting enough question? How do I want to get the number in a simple way? Yeah, I mean, we could just do like a linear search for something, but the problem with that is that could be pretty inexpensive. It could be expensive. You know, if we're like kind of loop through all the numbers to find an opening, like that's not really very efficient if you do that every time. You could actually you could cache the get numbers. In other words, when you release a number, make that the next number you get. And otherwise, make it a number that you know is not, a number that you know is available. Yeah, I mean, that could work. So what you would normally get would be basically there's sort of a previous value that we maintain, which is kind of like, I guess there were holes. Now here's the thing: if you release a bunch of numbers, you could push those into a stack. I like that. I like that a lot. Okay, let's do that. Just do it that way. I like that. That's an interesting way to do it. So max numbers, previous, and a stack. Let's see if we can try that. Holes. Holes. Nice. When I never hadn't imagined that I would have a variable named holes or available. Put it that way. You know what we could do? We can do better than that. Forget previous. I have an idea. You ready for this? I have an idea. Okay. So we're gonna do this. We're gonna say standard vector of int. No, don't do that. Don't do it that way. We're gonna do it this way. Okay. For int I equals 0, I is less than max numbers, plus plus I. We're going to take available and we're going to push I, right? And then we're going to say get is going to say if available dot not empty, it's not empty. Pop from the stack. Ah, you like that? How do you like that? There you go. There you go. Available dot top, yeah. Pop. Red. All right. If it's not empty, otherwise, else, throw. Is it? Okay. There are no available numbers left. Okay. Let's push all our numbers into the available numbers into a stack. We don't really, yeah, we have this current numbers as well. Set also keep track. So if we get, we want to take from available and pop, and we also want to current numbers dot insert this value, and then check is going to be if number if current numbers dot count of number turn true. That's really it actually. And then recycle is going to be current if check number, then current numbers erase number, and available push number. Ah, I like that. Highlight that. So initially everything will be available and current numbers is empty. And then we don't really need this, do we? It's max numbers. It doesn't even matter. Oh, that does matter. Yeah, it doesn't matter. That's it does matter. I was thinking about it, like, wait a minute. No, that doesn't matter, because you can give it whatever you want here for the numbers. It doesn't say what we're going to get for these inputs. Yeah, it didn't say anything about what the inputs are going to look like. It said a little bit, but it didn't say, yeah, that we get some crazy input for the check and also release. And excuse me. Right. So if it's available number, then we can release it. If it's not available, then we don't do anything. It doesn't do anything if we try to release something that's not it doesn't exist. And then to get, we just grab some number from the stack of numbers that are available, and then when something gets released, we push it onto the stack. That available number becomes available again. And the stack will just kind of keep bouncing around through different numbers. That is awesome. I like that. Sweet. I like that approach. Yeah, it's an interesting question. I like this. Oh no, it's wrong. Here I am, like, so excited, and it's wrong. It's like, wait, what? What do you mean it's wrong? Excuse me? Oh, okay, I guess I guess we have to, alright, we'll make it a queue then instead of a stack. How, why, alright, whatever. Does that really matter? That shouldn't matter. We could push in the stack backwards, right? Can we do that? If there's an order that it has to be, it's kind of annoying. Could push in the stack backwards. Why is it wrong? What do you mean it's wrong? It doesn't, it shouldn't matter. Memory limit exceeded. Oh, no kidding. Nice. Don't mind me. Just making mistakes. Still wrong. Really? What? Get 0, get 1, check. Can return any. This is really funny. Like, what are these test cases? What do you mean? What are these test cases? This doesn't make any sense. Alright, anyway. Can return any available phone number. Here we assume returns 0. Assume returns 1. Okay. Number 2 is available, so return true. Ah, I did this wrong. It's the other way around. It's and not. If it's not already in there and it follows these two things, then you're okay. So so our check is a little bit different. So we probably would just want to do yeah. That's fine. We could just put this in here, down here, as it is. I was going to use this check as a subroutine, but it's a little confusing. This is checking if it's available, not if it's being used. Okay, so that was probably what's wrong. I guess this doesn't matter if we go the other way. My buddy! Oi, my buddy! My buddy! Okay, they don't care. It was just the check was wrong. I misunderstood the check. I could read, you know. Kind of like this better. Get the larger numbers first. This is a simpler loop. Or I should say, I'll just say I prefer this. So okay, so the check. Yeah, the logic for this check would be kind of awkward, right? Because it would have to be this. It's not the same thing as this, right? You don't bother to release if it's not in range. You would say not check, but the problem with the not check is that it includes these other pieces of logic, which, yeah, it's just better to just specify it all the way through, because these are different. Anyway, okay. Do we just go for it? I think we just go for it. How much time we got? How do we do? Almost 20 minutes. I'm nervous to go for it. We're gonna go for it anyway. Okay. I knew there was something. I knew there was gonna be some test case that we fail. Like, of course. What should you return in this case? What do we do? So check 1 is false. Get, we should get check 0, get, check 0 again. So this should be false. We get a number, we check, and it should be false again, and then we get again. What? Oh, this tells us how big the phone directory is, though. Okay. So it's false, true, or yeah, false. We get 0, and then true, and then get again. What happens if It didn't really say if what is expected here. Hold on, what? What are they expecting? I mean, I was assuming that we weren't going to try to get more numbers than is available, but I don't know what is going on. Wait, what? 31? What is the issue here? Hello? Oh, okay. I don't know. Oh. Really? What? What? Okay. Excuse me? What? How am I supposed to know that? It doesn't say that anywhere. Runtime error is so much better. Oh. Okay. Yeah. What? What? What is this? Are you kidding? Is this a joke? Seriously? Come on, man. I got. I'm upset. Yeah. So if you try, if all the numbers are already taken and you call get, my opinion, you should have a runtime error, right? Because you have a failed expectation of some kind, right? Like it's not working. It's supposed to work. And what are you supposed to do? Like just give a random number that doesn't exist, right? And so apparently you're supposed to just give them a -1, which doesn't, like, that's not good. I mean, you can, but it's like it's better to just throw an exception, I think. Yeah, I would say you just don't test those test cases because those are sort of faulty test cases, right? Like those are explicitly incorrectly you're incorrectly using the object, right? So like you'd just throw an error if you're not using it correctly, an exception. And then obviously whatever's using this object would try to handle that somehow. Tell the user, hey, it's doing something wrong here. So apparently it's not right to throw the exception, which is so weird. I don't know. I don't know what to make of this. I don't know. We're gonna go for it though. There we go. Okay. All right. I'm not crazy. I thought I was going nuts, man. I was like, I'm trying. I thought it was so smart, so clever. I thought it was like this pretty clean, pretty relatively easy to understand, easy to implement. Like this was like really nice. And if I got an interview question like this, I'd be a pretty happy guy. 23 minutes took us. Like we're in good shape here, or at least I thought I was. And then, boom, we had this shenanigans going on here with runtime exception or returning just a random value, really. Let's say, what do they call it? Say. Like it's not a sentinel. Is it a sentinel value? I think that's what it's called. Sentinel. Like what is this? Signal value. Yeah, trip value, flag value, special value, context of algorithm, which uses its presence as a condition of termination. Basically just like a value that represents that a failed that basically a value that represents this failed case, I guess, or this non-case failed case. I don't know what to call it, but this is kind of not the best way to do it, in my opinion. I think throwing an exception is better. But anyway, all right, so pretty good. I mean, we got the reasonable runtime, reasonable memory usage. I like this approach. I think this is pretty efficient overall. May not be perfect, but it's relatively good, in my opinion. Yeah, okay. It's clean. All right, so thank you for watching. I hope that was interesting to you. I'm just going to check something quickly before I go. So yeah, I'm going to go ahead and end stream here, or end this topic and this question problem stream. And then hit hit the gym, take a shower, get some food, and may or may not come back. I don't know. I might want to just like sit and cozy up with my Bible, read the Bible for a while. That would be nice to do. That would be a nice thing. So yeah, I don't know what I'm gonna do, but I'm gonna go. So take care.